Welcome to my presentation for the LINHAC student competition, Where Did They Get Out? Evaluating Zone Exit Using Expected Threat in Hockey. My name is Keller, I'm a student of computer science at University of Basel in Switzerland. Why do I want to talk about zone exits? Zone exits are two things at once for me. They are the start of an offensive sequence, but also could be a successful defensive sequence, or mostly are, in the form of a control zone exit, and in that form they decrease the danger of the opponent. But are all zone exits the same? That's a question I ask myself. And is there an impact of the exit location on the opponent danger? Because my personal observation was zone exit over the sides are more effective in danger reducing than zone exits through the middle. Is that really true? That's what I wanted to look at in this project, and I used the concept of expected threat that was is based on Sarah Rudd's work on research on evaluating actions in soccer with Markov chains, and was formalized into the form we know today and mostly is used today as expected threat, or XT, by Karun Singh. The idea is to add a value to every section of the field, and that value is the probability of scoring from that position in a given set of moves. The difference of sections from the beginning point and the end point of an action is the value added by that actions. To translate that into hockey, I divided the ice surface into a 16:9 matrix that you can see on the screen, and I used passes and carries as the moving actions evaluated. Then I used the Markov chain technique to calculate the transition matrices after 8 moves. That's the best, where I got the best values, and got the XC matrix for offense. Then I flipped the values around so that it makes sense for defense, and got the defensive expected threat values. By combining offensive and defensive expected threat, I got a net XT values that encompasses both the danger reduced and the danger added, danger reduced defensively and the danger added offensively. I also used the concept of exit lanes, exit sequences first, that broke by breaking down the event data to sequences leading up to a zone exit to evaluate the actions before the zone exit. And I also used the concept of exit lanes that is similar to work on zone entries with zone entry lanes by Daniel Weinberger and Nick Schulman. And there's two different ways to define the exit lanes: one by the location of the event of the zone exit, and the location of the puck where the puck approximately crossed the blue line. I decided to go with the location of crossing the blue line because you can see in the middle there's a lot of different values for the exit lane events in the middle, but it is not necessarily where the puck actually crossed the blue line in the exit event. Then with my results, you can see that in the left and right lines we have the most events, but also the most events that are net zero, and we get the most extreme results in both directions, because there's like a lot of events that are some really good ones and some really bad ones. And you can see that really good plays through the middle get rewarded a lot because you decrease the danger in the middle a lot, but you can also be punished for these exit events. And yeah, we can in the end also see that the values are not really conclusive enough to show that the outside lanes are better for preventing or creating danger. But what did we learn from that? Or what could we also work further after the project? One thing probably to look at would be what happens after the exit, not what happens before the exit, because it's interesting to see what happens if a player exits through one of the 5 different lanes I defined, and also how do different pass and carry types affect the exit. For a good example here would probably be exits by passes over the board. And yeah, that's it for my presentation. Here's all the sources I used for my project, and thank you for your attention. Thank you very much.